if we were going to write the general idea for a lineup or a queue with an interface, I'm going to use the computer science terminology and call it a queue. And this is specifically going to be the general idea. So here's this general idea of a lineup you see. Kinds of things you can do for a lineup. You can join or add or stand at the end of the line. We could use the word add, but like stacks, queues have been around forever in computer science, and they just happen to have a specific name. So the thing to actually add something on to the end is not add or add to end, but it's public void enqueue, just to make your life difficult to type. What kind of thing are you going to put into a lineup? Could be object, could be any old thing. So we'll use the idea of any old thing could be added onto a queue. Oh, nice. And if anything can be added on, it's me. If anything can be added onto a queue, E is the thing that gets added. Okay, so this could just as well say add. What's it upset about here? Oh, I said class, and because this is a general thing, there's the word abstract, or sorry, interface on it. So there's the general idea. Okay, so you can add something onto a lineup. Could be a person, could be a lineup of dogs, could be a lineup of cats, whatever it happens to be. What other thing can you do with your lineup? Take the first one off, and just to make your lives difficult again, using the standard terminology, it's called DQ. So it's NQ and DQ. Wouldn't it be nice if they'd said add to end and remove from front? Well, yeah, unfortunately, that's what it is. Anything else you need to know about your lineup? What's the question you ask when you go and look at a lineup? How big is it? So there's also got to be a public int size. Tell me how many people are in the lineup. Okay, so that's the most restrictive form of a lineup you can add, period. Always add to the end, you always remove from the front. How many people are in the lineup, period. Okay, I always think of this whenever I see a queue. For some reason, I always think of movie theater. And so I always think you're always adding to the end of the lineup, and there's somebody at the front of the lineup who's busy serving customers and basically trying to make the lineup smaller, right? Throw away the items on to get people into the theater as fast as you can go. Okay. What other operations could we add if we wanted to be a little bit fancier? Instead of a standard lineup. Even if it is a standard lineup, what's another question you might want to ask? Well, you already know if there's anybody in the line.
What about average weight?
What's the question you ask if you're standing in the front of a lineup and you're way at the back of the lineup and you're looking towards the front?
Is there anybody I know that I can join?
Well, not anybody, but who's the most important person? First person in the front of the line, right? I mean, that's the, oh, let me see who's at the front of the line. Who's that person, right? So that's quite often a really important question. So we could add a peek function here that said, just tell me who's at the front of the line. Okay, so that would be the next obvious thing. Suppose we want to relax the rules for queues. Let's now talk about bar lineups. Here's my VIP card. What does my VIP card do for a bar lineup?
Front of the queue.
Front of the line. Okay, so special case. If you want to do just a single special case, it's people who have a VIP card who are special get at the front of the line, which means you go before anybody at other VIPs, right, at the end of the other VIPs, but before the regular people, right? But there's some sense of it's at the front of the line rather than the end. Okay, so there's another special form of a queue, a VIP lineup. How about a hospital? What kind of lineup do they have?
depends on.
in the emergency waiting room, what kind of lineup, how does their lineup work?
Highest priority.
How fast is this person dying?
So it's a priority queue, which means that people can be in the queue already, but when somebody comes in, they're assigned a priority and they're placed someplace within the queue, neither at the front nor necessarily at the end, probably at the end if you've got a small complaint, but someplace that's based on your priority. Okay, so the fancier form of a queue that you're already used to is a priority queue, where you go and you fit someplace in the lineup according to some criteria, whatever that happens to be. Okay, and notice with a priority queue, people can come in and jump in front of you in the line just like a VIP queue. You don't necessarily go in order served. Okay, now here's another special thing about queues. Queues almost always have the sense that there's two participants in the game with a queue. And again, in the movie theater example, you can think of having a greeter at the movie theater whose job it is to take people to the end of the lineup. Okay? So there's one person whose job is to do nothing but try to fill the end of the lineup as fast as they can. And at the front of the lineup, there's another person whose job it is to try to remove people off the line as fast as you can. So it's really a competition, right? Somebody's trying to make the line longer at one end and somebody else is trying to shorten it up at the other end, but there's this idea that there's two participants in the game. So it's one of the few examples that we're going to have in this term where instead of one person like we had with a stack putting things on and taking things off, it's really quite often a two-player game. And so most of the time, queues are used with the sense of two players, I've got more information coming in than I can process, so we need to build this lineup. Okay? So quite often they're used in computer systems. They'd be used for something like, I've got some stuff coming in the network, it's coming in too fast. I need to put it on some sort of a queue to hold on to it because I can't process it fast enough. There's somebody holding on to the stuff that's coming in, and there's somebody else busily trying to process it. Okay? So it's usually a two-player game, which makes it really unexciting as a one-player game. And so what I'm going to do for an example later on is I've got an example where I get two independent things going in a Java program, just so that you can get the sense of things being added versus things being taken away. Okay, so let's work with there's the simplest form of a queue. So let's write some code to do that sort of stuff. Let's make a new Java class, and let's call it a queue, and we'll start out by using an array to hold on to it. So here's a queue with an array underneath. And we'll do the promise for this queue that this thing, which can hold on to any old thing, is going to implement queue interface for whatever those type of things happen to be. And now the IDE will complain and say, you're not fulfilling your promise. We'll get it to add in the method stubs for us, and now we can figure out how to write the code. I'll give you a head start. I said for this, I want to use an array of things underneath, so I'm going to have a private E array of whatever kinds of things there are. To start with. Need a constructor. Here's my QArray constructor. Need to initialize all items. And this is the weird syntax. You want to say make a new E array of some size. But the syntax doesn't allow that. So there's the special trick here that says, well, what we'll really do is we'll make a new object array, and then we'll say, oh, no, really, I'm only going to hold that specific type of thing in it. So that's the little weird Java syntax for getting that to work. At this point, we won't worry about the fact that it's only 20 items left. Here's my queue. If I say make a new one, it makes a variable that's going to hold on to all items. And all items is now referring to an array where we can hold, in this case, 20 things. Okay, so let's play the middle of the road game. Let's suppose that we've hooked up a bunch of people to stand in this lineup. Here's first, second, third in the lineup. Suppose that now somebody else comes in and wants to join the lineup. We need to say this is the next empty slot. This is where we're going to put them. So we need now another next empty variable to keep track of the position that we're filling. So there's some sense of I still need to keep track in my array of where the end of the line is so I know where to put people. Okay, so there's add or enqueue. What happens if I do dequeue? Which one am I going to select? Select the first one. If I select the first one and say there's the first person who's in the lineup, what do people in the lineup do? Everybody has to shuffle forward in this thing, one towards the front of the line in order to say, okay, I'm now one better than I was before. Anything bad about that? Efficiency-wise, this is really a silly thing to do because we've got one operation that's really, really fast, and we've got another operation that's as slow as it could possibly be, because if there's 1,000 people in the lineup, it's literally like the physical thing. Everybody in the lineup takes one step forward. Okay? What would, if we wanted to avoid everybody in the lineup at the movie theater having to take one step forward, what would you do in the modern world with the lady in the ticket office?
Reservations or like online.
No, still got to process the lineup.
Get her to move.
Do say that again?
Get her to move.
So get the person who's selling tickets, instead of them sitting in the booth, if we give them a portable, MasterCard thing and ticket printer, then that person who's going through and trying to make the line disappear can run down the block just processing tickets and trying to make the line disappear. Any problem with that? It makes it convenient in the sense that all of the people in the lineup are together, but where does the lineup end up going? It heads up way from the theater, way down the block, and disappears off into the distance. The more people that you have, and it's like, well, hold it here. There's this big empty spot between there and there. How could we fix that? Remember, we've got this person who's directing people where to go stand at the end of the line. What does that person do at some point instead of firing people down off into the distance?
Put them in an empty spot.
Put them where?
That's close. That's a thing.
So at some point, the person who's in charge of putting people at the end of the line says, well, hold it here. Now I've got this big space at the front, and I've got somebody's processing these tickets. It would be more convenient if I stopped putting people, instead of putting at the end of the line here, I directed people to come back and stand right at the front of the theater again and just let that person finish off taking the tickets in the end, and then she can come back to the start to this new line that I formed. Or, in other words, reuse the spaces at the old beginning of the line to put people in place. So, if we were to draw this on the diagram and we only have these few slots available to put people before we run out of room at the end of the block, right? We put people in here, the lineup's formed. All of a sudden, ticket agent starts coming along and says, oh, I'm going to start selling some tickets. this person's turning around and saying, oh, I'm just gonna keep adding people to the end of the line. Eventually, when they run out of room and they can't add any more people because there's no room at the end of the line, they run into a wall or something, what do?
They check to see if the front has any empty spaces.
They turn around and they go, oh, look, I've run out of room, but I've got empty spaces at the front. If I'm lucky, I can start putting people back at the front again. This person is gonna still keep taking tickets, and so now it's a race to just keep reusing this space. So this is now the front of the lineup, and the end of the lineup is here. And you're sort of hoping that you've somehow got enough space that there's always room to put people in this recycling area that you're using, and that these two never collide and run out of space. And the front one keeps going down here, and what happens is when the ticket agent runs out of people there, they run out to the end of the space they've got, they go back to the beginning and go, oh, look, there's more people there, let me just keep taking tickets again. Okay? So there's a trick to this game, which is not to do the shuffle at all, but to just reuse the existing space when you know it's available, when you get to the end. So it's when you get to the end that you go, oh, I need to go back to the front where I was placing people to begin with. So now that we got that settled, let's go back and think about what it means to add somebody onto the list. Let me just draw the diagram sort of this way, and we'll forget all the link stuff in there, and we'll just do it this way. Here's our lineup of people, and let me do the general case. What are the important things in the diagram?
Where the lineup begins and where the lineup ends.
So this is begin, and this is end, and this is maximum. Okay, so this is actually, since this is a number, I'm going to call it begin position, and I'm going to call this one end position. Okay, and so what we're going to do is actually maybe end position is better rather than referring to the end. Let's slide it into that idea of next empty position. So instead of end position, I'll call it next empty, to give the sense that there's nothing there, so that's a good place to put things. I'm being more specific about what it is. So if that's the next empty position, this one is the, in terms of that word, next full position or first full position. The idea of first being, here's the one I'm going to go grab, the fact that there's somebody there. Okay. So I'm going to make two variables here. Make last empty position that, and we'll make first full position. Okay, so I want those words on there to be really specific about what's going in there. Okay, so I'm never going to try to drag something from an empty position because it's empty. I can't go use that to get something. What value should last empty position have to start out with? If we've got nobody in the lineup to start with, then the place where people can start going is just into position 0. What about last full position, or sorry, first full position? There isn't a full position yet, so this one's a little strange. It's like, I could put a 0 in there, but that's a little bit of a lie because there isn't actually anybody there. I could put a -1 in to try to indicate that there really isn't anybody there because it's not a valid position, but that would mean I would have to increment it before I start it. Maybe. We'll give that a try. Well, before I even do anything special here, let's talk about size. What value should I put for size? If I were going to say, if somebody says how many people are on my lineup, let's go back to a lineup that had something in it. How many people are in the lineup? I could take 5 minus 1, so that's empty minus full position, to give me some number which was the number in between those two variables. Okay, that sort of works. But what happens if this thing wraps around and now all of a sudden next empty is actually over here and first full is someplace over here, and now they're backwards? Well, notice what happened is, like, even though this is fairly simple math, your eyes are rolling and going, oh my God, this is going to be some sort of a problem. I mean, if we did next empty, if we took the normal case and did add next empty minus begin, that would give us a number. Maybe if I took the absolute value of that plus or minus 1, it might work out, don't know. But I could probably come up with a numerical calculation to figure out what it was, right? What's the simpler thing to do? Let's just count them. And then we don't have to worry about the calculation. So let's put in another variable here that says we're going to start out with nobody on the list. So we'll make our variable item count. And now what happens every time you add somebody to the list? What has to happen to item count? Item count has to go up. We know that for sure. What happens if you remove people from the list? Easy. In this case, item count, before you're done, you now know it's gone down by 1. Okay? So we keep talking about how would programmers have done it in the old days versus how would they do it in the modern world. In the old days, programmers would have said, if you go and look at code, they would have said, oh, okay, somehow magically, if I sit and think about it, I can figure out the math formula or do some twists and turns to figure out how to just use those 2 variables only to figure out what I need to do. And they would spend a whole bunch of time worrying about how do I use 2 variables there rather than 3. In the modern programming world, it's just easier to go, I don't really care. If I just make another variable, it adds 1 here, subtracts 1 there, work is done, didn't have to think about anything. Okay? So the cost of another variable in the grand scheme of things is no longer important, so you might as well write the code that's simpler for human beings to understand than the more complicated mathy type code. And that's pretty much guaranteed to be correct, as is. If I were to do the math formula for that, not being particularly good at math, I would probably spend the next hour trying to get the math formula right for all of the cases. Don't have to worry about it. Save myself an hour of time just by using another variable. Okay? So now we know how that thing works. So now it actually probably doesn't even matter about that variable, but that's okay. We'll just set it to 0 now and see what happens. Maybe I'm no longer worried about it. So when you NQ people, do the regular case first. Write the code for what you would do normally. When somebody says add 1 to the lineup, where do you put them? Put them in the next empty position, so that's all items at the next empty. And notice the word empty there emphasizes the fact that it's okay to put something there. So the thing at that next empty position holds on to whoever wants to join the list. Guess I'm not spelling last empty position, sure. So it'll, yeah, let's call this one next instead. I like that better. Got it. So if somebody wants to join the lineup, we add them to the end. Now what happens? So now next empty position has to refer to the next one, and then item count goes up. Now, I'm not worrying about the special case yet. Don't care. Just assume that I've got infinite room to put a line up. People just keep marching along, taking stuff. Fine with me. I'll go back and I'll worry about the special case later. Suppose that I want to remove somebody from the lineup. What happens? Just in general. Who's the interesting person? So the interesting person first in line is where? It's in all items sub what? In general? It's in the first full position. So if that's the one we were interested in, then we'll change this thing to say first in line needs to be sent back. What would happen to first full position? It has to be incremented. So first full position now has to advance to refer to the next one in the line. So this is this idea that somebody's moving down the lineup, selling the tickets with their portable ticket machine as they go. Size is really easy. That's item count. Okay. In NQ and DQ, we've manipulated all items, next empty, first full, and item count. Anything else that has to change? In NQ, we'll ask the question this way. Does first full position change? Should it have to change? If I'm adding somebody to the end of the lineup, hasn't done anything to the start. What about if I'm removing somebody from the lineup? First full position changes. Do I worry about the end position? Shouldn't be touched. Okay? So in this case, it's really specific that NQ only cares about the next empty variable, and DQ only really cares about the first full variable. Okay? And that's a really important thing about queues, because those come in handy later when you're doing threaded code and you don't want things to interfere with each other. That queue is going to be a really helpful little technique. Okay, so we've got NQ and DQ. It looks like they're set to go. How about some unit tests? Now's the time to go and say, oh, maybe we should write some unit tests. I put a worker object in here. Can we reuse any unit tests that we've got already and morph them a little bit? What unit tests look, what's the thing that looks sort of kind of like a queue but a little bit different? A stack. The difference between a queue and a stack is a stack we're putting the first one on and expecting to get the first one back off again. In a queue, you put some things on and then it's always take from here and add to here. So it's sort of like the reverse problem. So it's enough of a look-alike that what I'm going to do is I'm actually going to go and I'm going to steal the stack array test and I'm going to dump it into my Q code, and I'm going to change the name on it to Q array test. And now that I've got what is the start of my Q array test, I'm going to go take a look, and instead of saying stack interface, I'll say Q interface, and we'll talk about a queue. And instead of making a stack linked, we'll make a Q array. And maybe I'll make an extra worker here. I'll make C just for the pure fun of it. So we'll need to make another one of these just to get some extra stuff to put into our lineup. And instead of a stack, I'm going to refactor this to say it's really a queue. Oops. Sure, close enough. And now, to test one item, we put one person on the queue, which is NQ. Size of the queue should be 1 because there's one person on. And if we dequeue them right away, add them to the line and then remove them, it should be the person we just put on the queue. So there's the simple case. More complicated case, we put A on the line, we put B on the line, we take something off the lineup. Who should it be? So it should be A in this case, and there should still be one thing left on the list. And if we take the next one off, then the one that should come off the list afterwards is B. Okay, we could put C in there too, just to make it a little more complicated. So test to see if 3 work, etc. But you get the idea. Okay, so we can run the thing, our unit tests, and oh look, we can do a lineup. Not particularly exciting. What's wrong with the code that we've written so far? What's another unit test? Well, what's going to happen at some point with just the code that we've got? What's our code going to do if I add 100 items? What's going to happen? I'm going to go off the end of the array because I've only made an array that's 20 large. Right? So at some point I'm going to run off the end of this thing, and I want to prevent that from happening. So what would a unit test look like? Just in general, if I were to write a unit test, add more than 20. You know, 20 is just the maximum size I can fit in one room, but hopefully they're not going to show up all at once. So I'm going to try to process them out of the line, keep those 20 slots being reused. So I should be able to process 100 or 1,000 as long as I never have more than 20 at once. So if I keep doing add, take, add, take, add, take, I can go on forever. It's only when I do more than 20 adds I'm gonna go. So simplest unit test is to do what? if you look at the diagram, what would you do for a unit test? Try filling it like this, but the legal thing is I could still remove a few to create room from here, and the rule is if I eventually get to the end of this thing, my code should somehow reuse that room at the beginning, and it's not doing it right now. So the test is actually really easy. The test is add 20 items, remove 2 or 3 from the front, and then go add another one, and then make sure that the things that are left over as I remove them include all of those ones that include all of these plus any new ones that I add to the front. Okay, so there's the sense of the unit test. Okay, so rather than writing the unit test, let's talk about how would I morph this code so that it did the wraparound trick. What's wrong with this code as it stands with the NQ? So which variable is the one that's causing the problem? So what's the special case for next empty position? If it ever gets to the maximum, it's actually gone over the end, it needs to be reset back to the front. So the simplest thing to do here would be to say if next empty position ever reaches all items dot length, which is the end of the room, then what would you do? It needs to be set back to 0.
What if the first person hasn't cleared out yet?
We won't worry about the case of we run out of room. Let's worry about the case first of, gee, can we just reuse the space and pretend that we never run out of room. Okay, so the reasonable thing to do is just reuse the space first. Any other changes we have to make to the code? What about DQ? Same thing. DQ, if you've ever processed all of the people, the person who's holding the ticket machine, the MasterCard thing, reaches the end of the line, then it's like, oh, I've reached the end of the room, let me go back to the beginning and let me start reprocessing people. So that also needs to be set back to the beginning. So that's the same piece of code, right? If next empty position, first full position happens to reach the size of the thing, oh, I guess we just have to do all of that all over again. Okay, so that should fix it. Because now if any of them ever run off the end, they just reset themselves back to the beginning and keep on moving through, reset, keep moving through. Okay, should work. Anything evil about what I just did? What's the evil coding rule that I just broke?
Not escape.
Suppose that for some reason I don't know, didn't get this one right. What I did was I just copied and pasted so that I now got basically a version that looks like that, which is now broken. Notice what copy and paste did to me? It took something that I hadn't even tested yet and put the code in 2 different places. It's virtually the same piece of code, So now even if I go, oh, okay, let me correct this bug here, that should have been right to the end, I've now got a piece of code that still has the bug in it. Okay? So the point I'm making is that when you are writing code, copy paste is never ever your friend. Because what it does is it takes the possibility of error and propagates it throughout your code as many as times as you copy and paste, and somebody's got to go back and fix all of them. So what would be the better solution? Turn this thing into a function to do it just once and always call that function. So let's just think about this. What we'd do is we'd want to take, we'd want a function called, say, wraparound, and we'd pass it next empty position. So what should we get back as a result? In this code, what happens if you execute this if statement? Well, okay, let me just combine these together. We did that first, and then we checked to do the wraparound. So the result of that, I should have moved this, let me just move this out of here. And that'll make it more obvious. So there's the code that we had before. That stuff is all tied together to get it right. So if we replace that code, if I put next empty position in here, what should come out the other side? A number which is either what or what? 0 or 1 greater than it was before. So regardless of whether we get 0 or 1 greater than before, what goes back into this variable, we'll put it back into the next empty position variable. Okay? So for you math people, that's x equals f of x. X changes based on the value it had previously to something different. Plop it back into the same variable. So next empty position is either going to come back as a 0 or it's going to come back as 1 bigger. Either one is good, and that code gets replaced with something that looks like that. What does wraparound do? It's private int wraparound. And it takes an int current position coming in, and it's wraparound that has the if statement inside it, and that code that we replaced is we'll take current position, whatever it happens to be, and we'll increment it, and if current position has reached the maximum number of items, then current position needs to be set back to the beginning. That's almost right. The one I just took out. Sure. Run source format.
Not returning anything.
And then we need to return whatever current position is. Oops. Okay, so now look what happened to NQ. NQ says we add an item to the next empty position. Next empty position changes to refer to some other position. It's either 1 more or it's back down to 0. And then item count goes up. What do you do when you're given a position? You increment it, and then if for some reason it's gone off the end, then you set it back to 0 and you send that number back instead. So now that means that this if statement that we wrote in the other case of DQ just gets replaced with the same piece of code, which first position equals wraparound of first full position. And so really that work went into saying, I can reuse that code if I put it in a method, and now that code, that if statement and the incrementing of that variable are tied together and only occur in one place in your code. So if there's a bug, only one piece of code that ever needs to be changed from now on, not two pieces of code, or three pieces or four pieces of code. Okay? By the way, all of this stuff can actually be replaced with a lot simpler mathy type statement. Because when you do a division, 12 divided by 3, actually 13 divided by 3, we'll do 14 divided by 3, how's that? 14 divided by 3 is 4, remainder 2. So when you do integer division with the division sign, you get the 4 part. If you use the percent sign, you get the remainder of what's left over. Okay, so 4 divided by or 14 divided by 3 gives you the 4. 14% sign 3 gives you the 2. And the joy of our getting the remainder is that the remainder is guaranteed never to be any bigger than what you divided by. Okay, which gives you the wraparound. It can never be larger. Okay, so the way that you'll sometimes see this written is we'll add one. I'll just do it as a one-liner. It would be add 1 to current position, and then current position is current position. Yeah. Current position, percent sign, or mod operator is what it's called, all items dot length. Or if you wanted to get really fancy, C programmers would do that. And then basically all of this code is no longer necessary. Okay, I've left that in some of the examples. I think it's even in the notes commented out. I don't like that because it just obscures things. I find that people are a lot better off understanding the slightly longer if statement. I added 1 to it. Oh, it got too big, it needs to be reset back to the front is something that people understand a lot better than the mod operator. Okay, but again, either one. Okay, so there's your queue. That's queue with an array underneath. Tomorrow what we're going to do is we'll talk about lab 3. I'll go over the lab 3 solution. I'll write it before your very eyes. And then we'll move on to doing queue. Instead of using an array, we'll use a linked list so that you can get more practice at chaining things together with a linked list in the